Welcome to another episode of AI Talks with Chris and Nita. I always look forward to our sessions. Today we're going to dive into ensemble learning, and I think it's so cool. It's like these AI models are teaming up to become like even smarter. So how does this teaming up actually work? I mean, how do they actually become smarter?
Well, it's pretty brilliant. Instead of relying on just one single model, which, could have some gaps in its knowledge, we actually combine the predictions of a multiple model. Think of it like a panel of experts from different fields all coming together to solve a problem.
Okay, that makes sense. So like instead of just like one person kind of looking at it, you got a whole bunch of different perspectives.
Exactly.
So, but then wouldn't that make things more complex? And how do we know like what the trade-offs are there?
That's a great question. And that's kind of where the art of ensemble learning really comes in. You're absolutely right. It does get more complex. But the gains in accuracy often outweigh those costs, especially now that computing power is so much better than it used to be.
Oh, so it's like we finally have the power to really do it, right?
Yeah.
Okay.
Yeah.
So essentially ensemble learning is just about combining these models in like the best way possible to get a better prediction than you could from any single model.
Exactly.
Okay, so how do we go about combining them? What are some of the ways we can actually do this?
Well, there are three main techniques: bagging, boosting, and stacking. And they all have their own strengths, each one suited for different situations.
Okay, cool. So let's start with bagging. Is that like the whole pull yourself up by your bootstraps thing?
You're closer than you think. Bagging actually stands for bootstrap aggregating,
Okay.
and it creates multiple data sets from the original data by resampling. So it's kind of like if you took a deck of cards and you dealt out several smaller decks,
Okay.
but each of them slightly different. Those represent our diverse data sets.
Okay.
And then we train a separate model on each of those decks, and we average their predictions.
Oh, so it's like you're getting multiple opinions
Right.
from slightly different.
Really different perspectives.
Exactly. So it's reducing like the chance of overfitting, you're saying.
Exactly. We don't want to just overfit to one particular set of quirks in the data.
Gotcha.
We want to generalize. We want it to be robust.
That's a really clever way to do it. So what about boosting? How's that one work?
Okay, so boosting focuses on improving the models sequentially.
Okay.
So we start with a very simple model, we train it, then we train a second model that focuses specifically on correcting the first model's errors, and we keep doing that. Each model learns from the mistakes of the one before it. It's kind of like a relay race, where each runner learns, if the guy before him stumbles, he learns how not to stumble.
Learns from those mistakes.
Exactly. And ultimately, the whole team gets a much faster overall time.
So are there any times where boosting would be better than bagging or vice versa?
Yeah, definitely. Boosting is often really good when you have data that's super complex, when there's a lot of nuance.
Okay.
It can really tease out those subtle patterns by focusing on the areas where the model's struggling.
Got it.
You got to be careful because it can also be more prone to overfitting.
If it's not tuned, right?
Exactly.
Okay, that makes sense. So what about stacking? What is that?
All right, so stacking, you're literally stacking things on top of each other.
Okay.
You take the predictions of all these different models, right?
Yeah.
And use a meta model.
A meta model.
Yeah, so we take the output of all those base models, and that becomes the input to train this final model, this overarching model. It's like the super panel of experts, where each member brings their own, unique expertise. And this meta model, it makes the final decision.
So it's like a team captain, kind of.
Yeah, exactly. Leverages the wisdom of all the subordinates.
Wow. So just to recap, ensemble learning is about combining the strengths of all these different models to improve accuracy, robustness, and generalization.
You got it.
It's incredible. Like, this is a really cool field.
It is.
I mean, there's so much you can do with it.
Absolutely. And that's what makes it so exciting, right? The possibilities are kind of endless.
Yeah.
If you think about how this concept, like combining strengths, how that applies not just to AI,
Yeah,
but to so many aspects of life and decision making.
that's so true. Well, thanks for joining me for this deep dive on ensemble learning.
It was my pleasure. Anytime.
Awesome.
Yeah.
We'll talk again soon.